Hi guys, here's Santos Bila. Today we're going to look at our tutorial 1. Let's see how does it look like. Very good. Assume a demand function given by this expression. Okay, we are being asked to calculate some derivatives. In this case, 1. In this case, 1. It says 1 derive the function with respect to price. Okay, something interesting that I want to remind you is the basic rule of derivatives. Okay, you can see it here. Okay, if you have any function to the power alpha belonging belonging to n, okay, is going to be alpha, the same variable to the power alpha minus 1. Okay, so we will do likewise. If we look closely at our expression, okay, we will say this is going to be 0, then this is going to be minus 10. Why? Because we will say p to the power 1 minus 1 is going to be 0. Anything to the power 0 is 1. All right. The second one is 0 because it does not have price. Okay. The third one is going to be plus a. Okay. The same rule applies here, right? Minus this one is 0 minus p. Okay, because if we bring these two to multiply 0.5 is going to be basically, it is going to be basically 1, right? So the answer is a partial derivative of this function with respect to price is going to be equal to minus 10 plus a minus p, right? We do the same here. We get the derivative of q with respect to a. It is going to be the same rule applies. Okay, this is 0, this is 0, it's going to be 40, right? Plus p, right? Minus 1.6 a. Okay, so very good. We will say with respect to a is going to be 40 plus p minus 1.68. All right, so for us to get the optimum value of POA, we will need to do some calculations. In other words, we will say these partial derivatives, they must be equal to 0. Then we will say minus 10 plus a minus p should be equal to 0. We can solve for p. We'll say minus p should be equal to 10, right, minus a. If we try to get rid of the negative sign, we will multiply everything by we'll multiply by minus 1, so we get p should be equals to minus 10, right, plus a. Okay, so this is going to be our equation 1. All right, so we will do the same here. This partial derivative must be equal to 0 plus p minus 1.68 A should be equal to 0. Okay, we will solve for A, so we will remain with 1 with minus 1.6. A should be equal to 40 minus P. Okay, if we divide all the expression by the same denominator, we're going to have A equals to, A should be equal to 25, all right, plus, so sorry, this is supposed to be minus, it's supposed to be minus, right? Okay, 25 plus 0.625 p. Very good. So this is going to be our equation 2. Very good. So what basically happens here is that for us to get the optimum value, we will need to substitute either equation 1 into 2 or 2 into 1. So I can just do it here, right? I will change the color so that you see. So you will have P is going to be equal to minus 10, right? Plus, we already know A by now, which is 25, right? Plus 0.625 P, right? So if we bring 0.65 to E, it's going to come to the left side, is going to be 1 minus 0 is going to be 0.375 P equals to 15, right? Then if we divide 15 by this, is going to be equal to 40. Let me just confirm. Divided 0.375. Very good. It's going to be equal to 40. So this is the optimum value is 40. Very good. So we will do the same here. Since we already know that this is 40, P is 40. So it's going to be way easier now, because we'll just take 40 and plug it in. We will say A is going to be equal to 25 plus 0.625 multiplying 40. This should be equal times 0.625. Very good. A should be equal to 50. So this is going to be equal to 50. All right. So for us to get the optimum value of quantity, we will just need to copy the same equation, all right, just to facilitate. Okay, then bring it here, and I will just substitute again I will say this is 40, should be times 40. This should be times 15. This should be 40 times 50. This should be 50. This should be 14. And this calculation should be equal to 508. 5,000, this should be equal to 5,800. Very good. 5,800. All right, so this is basically our activity 1. Okay, let's move on into our activity 2. The logic behind is the same. Okay, so it says assume that a firm must decide on an optimal combination of money spent on logistic L and on marketing expenses M to maximize total revenue. Assume the following total revenue TR function. Okay, so we will just do the same. The optimum value of L. That means we'll need first to do the derivative. Let's say we will derive. We will derive TR with respect to L, right? With respect to L. This is going to be equal to let's see, the first 4,000 is 0, this is minus 8L, right? The second one is 0 plus, right, M, right? The third one is 0, the fourth one is 0, then we will say minus 0.8L. Very good. So here we need to solve this for, we'll say this partial derivative should be equal to 0. Okay, so we'll say minus 8L plus 8 minus 8L plus M minus 0.8 L should be equal to 0. All right, very good. So let's solve for L. That means we'll say wait, this is not 8L, it's just 8. This is 8, right? Let's just make confusion here. This is 8, right? So let's solve for L. That means we will have minus 0.8 L should be equal to, it comes that side, 8 minus M, right? Very good. That means L is going to be equal to minus 8. This is minus 8, right? This is plus M, right? This is minus 0.8, right? Which is this one. It comes this side is plus, is minus, right? All right, so this is going to be minus 10. Let me just confirm. 8 divided by 0.8. Okay, minus 10 plus 1 divided by 0.8. 1.25 M. Very good. This is our equation 1, right? So now let's do our equation 2 to get one to substitute, right? The same applies here too. We need to get the partial derivative of the same TR with respect to m. This is going to be, again, this 4000 is 0, 8L is 0, we will say 30, right, plus L, all right, minus M. Very good. Again, this partial should be equal to 0. 30 plus L minus M should be equal to 0. All right. Solving for M, we will say minus M should be equal to minus 30 minus L. Right? This is just going to be equal to 30 plus L. Okay. This is our equation 2. All right. So again, we'll just need to substitute, right, in 1, and that's it. Okay. I'll just come here and say, I'll just change the color and say L is going to be equal to minus 10 plus 1.5. By now we know what M is. It's 30 plus L. That's it. And that's it, all right? So we'll say L is equal to minus 10 plus 1.25, 30, which is 35, is 37. Let me just confirm. Times 30. 37.5, right? Plus 1.25 L. Very good. So we will say if we bring this side is going to be equal to minus, let's go, 1 minus 0 minus 1 minus 1.25, 1 minus 125, 0.25 minus 0.25 L is going to be equal to 27, right? Let me just confirm. 0.5 minus 10. This is going to be equal to 27.5. If we divide this, L should be equal to 27.5 divided by 0.25 minus 110. That means the cut here is 110. The cut is 110. Very good. So let's do the same for M. Assuming that by now we know L is, we are just going to do this, right? Let me change the color. M is going to be equal to 30 plus, or minus 30 minus 110 minus 30 is going, the cut is going to be equal to minus 80. That means the cut here is 8. 8. Very good. All right, let's move on. The odd month sales revenue. The intuition is the same behind, the same way we did activity one. We'll just copy this. All right, copy it here, and we will say L is minus 10. Let me just confirm the calculations. Very good. And M is minus 80. Right. Very good. This, I'm just going to do this is okay. Let me say, yeah. Okay, plus minus 10 times minus 80. All right, this is going to be M is 80 is, oh sorry, is 80, and this L is minus 110. Okay, let me just do the calculations. Let me just do the calculations. Let me just do the calculations. Very good. So this should be equal to TR, TR should be equal to 3 to 40. All right. Thank you very much. This is our first part of our tutorial, and we will do our second part. Don't miss it out. If you have any doubt with regards to these two activities, just email us on santosneckersvilla@gmail.com, or you can just WhatsApp us. Thank you very much. See you in the next video. Bye bye.